All right, our next speaker, Peet, giving us a demo about modern flight software continuous integration for diverse platforms. Take it away.
Thank you. Jeff Young and myself work for a research center in the College of Computing at Georgia Tech that is called CRUNCH, stands for Center for Research into Novel Computing Hierarchies, and we operate this Rogues Gallery testbed. And I'm going to talk about, like we mentioned, the CI/CD part of it. I can talk, well, here's a little bit of a roadmap. I'm going to barely touch on the motivation because we've been hearing about motivation all week. I'll talk a little bit about the Rogues Gallery testbed itself, and I'll really talk more about the CI/CD workflow, and then there'll be the demo. So again, motivation, part of the whole point of the motivation here is to say that you can use the Rogues Gallery as part of your CI/CD, but it's not specific to Rogues Gallery. It's specific to needing to share a bunch of resources across a lot of people. So the Rogues Gallery itself is a NSF-funded post-more testbed for SciS researchers. I'm going to skip through a little bit of this so we can get on to the interesting parts. Why do you care about the Rogues Gallery? It's you can do programmatic or technology pathfinding activities. You can avoid administrating your prototypes while you're doing some testbed stuff. Maybe some stopgap in hardware access because we have lots of very interesting, very new hardware available in the testbed for the low, low price of promising that you're going to do some research and publish and cite me. In particular, that white box there is a 64-core RISC-V micro ATX form factor box with a discrete graphics card in it. So maybe those guys from Barcelona would be interested. All right, so modern tools. We've heard about modern tools all day. But the point is that the freely available solutions for these are typically supporting x86 and cloud solutions only, but the Rogues Gallery makes other architectures available. So really, the mechanics of accessing the Rogues Gallery, and this is probably the part that's interesting, especially, you know, Xian wanted me to put Nick's name on this slide here, but I'll try to keep the heckling from the podium to a dull roar. We have over 300 people right now, and we'd like to have more that represent the left side of this graph here, and they want to access these varying types of high heterogeneity hardware options that are within the testbed, and there's only about 150-ish items, although we grow that every day. But you have to be able to schedule this. And to schedule this, we use a tool called SLRM. There are more tools than just SLRM, but SLRM works really well for us. It's open source. We at Georgia Tech actually buy support from SCED-MD to help us with the hard parts of managing it. But we know a lot about how to use it in a non-HPC scenario because that's what we do with interesting, weird things, and we need to schedule access to it. So it's an HPC scheduler that allows you to schedule jobs across a widely heterogeneous resource set within a larger testbed. By the way, when I say testbed, to me, testbed means the entirety of all the things I have available, over 40 different servers, a cluster of pink boards, which is a Xilinx Zinc 7020 part on a little dev board. I have like 60-ish of those that I schedule. I set them up so that you can access them through Open On Demand with Jupyter notebooks, and it's kind of great for a class that we run about hardware architectures. But it also does partitioning and sharing of different types of resources, and it does accounting for specific resources with near-term. You know, we can do interesting things like preempt jobs if you have researchers with a near-term deadline, and other sort of priority-specific things. To leverage that, what I do, at least for CI/CD, is I use the batch job submission tool, and we basically, it's called SALIC. No, I'm sorry, it's called SBatch, And you can, but it's not the only access method. You can do live access, like either opened on demand or use salloc to allocate a node and jump into it and work on it in situ at the same time as someone else is scheduling resources on a different part of the testbed. So I have an example batch file here, which has specific it's requesting specific partitions and certain general resources, in this case a GPU, and it also has the ability to separate out some constraint options so that you can let the scheduler automatically select which resources you care about that meet the constraints of what you're trying to do. We also use this -w command flag in order to make sure that the CI, the return codes come back through to the CI tool that you're using. Let's get through that. So the workflow should be very familiar. The top half of that is really stuff that we've heard about already this week and that you should already be doing. But all of this is agnostic to the tools that are mentioned here. You could be doing this with, I don't know, Mercurial and Launchpad and running Jenkins jobs. But we are GitHub House or GitHub Shop, so we use GitHub Actions. We run self-hosted runners within the testbed that launch Slurm jobs and then build on whatever host you request. Well, I'm not interested in talking about that. So let's go to the demo.
Hello, my name is Sterling Peet, and I will demonstrate how you can leverage the Slurm scheduler via GitHub Actions to run CI/CD jobs on the Rogues Gallery testbed at Georgia Tech. I have tried to make the text legible for this demo. If it is hard to read, I apologize in advance. However, the slides, this recording, and the documentation for this usage of the Rogues Gallery testbed will all be posted online for later viewing. Let's start with a walkthrough of the demo project. This is a normal CMake project and follows the usual conventions. To support automated Slurm job submissions, I have created a CI workflow file. This workflow runs on pushes, PRs, and on a weekly schedule. We recommend the scheduled job dispatch to prevent the self-hosted runner from disconnecting from your project unexpectedly. There are two jobs, a normal cloud-based build and test job, as well as a build via Slurm job. This job requests the Slurm ARM and Slurm RISC-V labels. By applying these labels to your self-hosted runner, you have more control over the Slurm job submission process. The action invokes the sbatch slurm command to submit a job to the scheduler. I have put the batch files to define these jobs into the Slurm folder in the project. Let's take a look at the Slurm RISC-V batch file. The top of the batch file holds the options passed to sbatch. The job name is set. The option output file is set to ease the process of shipping it back to GitHub's action interface. The constraints are set to ensure we get a RISC-V node. We also set the capital W flag to prevent sbatch from exiting until the job completes. This carries the exit codes through to the GitHub Actions interface, signaling the pass-fail status to GitHub. The rest of the file is what runs on the build host in the Rogues Gallery testbed. This one has 4 parts. The first part prints some informational text about where the job was run. The second part builds the Catch2 testing framework. The third part builds the project itself, and the fourth part runs the automated tests. Let's build the project locally so we know what will happen when submitting a Slurm job. First, we generate the CMake configuration. Then we build the project. Now we can run the test suite, and we can even execute the demo application. If you've been paying close attention, you probably noticed that this project is largely a library that contains a function for adding 1 to the input and then returning the result. Instructions to install GitHub runners are located in the Settings tab of every GitHub project, so I won't cover that here. Self-hosted runners are generally run from the RG-CI Workflow 1 VM host in the testbed. And I do want to touch on some specific configuration. When installing and configuring the runner, we need to apply the labels it should pick up from the workflow job requests. I've added the Slurm RISC-V label. We also want to point the work path to the user scratch location to avoid filling backups with ephemeral build data. For testing out the self-hosted runner configuration, you can start it in Screen, Tmux, or use NoHup to keep the runner from terminating when you log out. I'll use Screen, start the runner, and disconnect using Control-A and then D to detach. Now we're ready to add a new feature to our project. Push it to GitHub and see that it builds our project on the Rogues Gallery testbed. Let's add a new function called add_to. First, we create a header prototype in the HPP file. Next, we'll write a test to confirm the functionality. Then we fill out the function's business logic. And finally, we exercise the function in our example app. We can build the project and rerun the tests. Since everything looks good, let's commit the project and send it to GitHub. When we switch to the actions page, we can see that the job is running. This is an example of how you can leverage SwRI to run CI/CD jobs on the Crunch Rogues Gallery testbed. I hope you find this useful. Thanks for watching.
All right. Any questions about how you do this? Or how you can get involved in the Crunch Rogues Gallery?
There are a couple of questions online. The first one is, how do you handle jobs that require coordinating across multiple physical targets?
Okay, so SwRI has a way to handle that built in by selecting how many nodes you want. And we just configure that there is a configuration for what maximums and minimums are, but it's a standard HPC style job, batch job submission that you see on supercomputers where you have hundreds of hosts comprising the compute volume.
Thank you. Next question. Slum still works great for the job scheduling, but have you compared against other modern tools like Airflow, which offer built-in support for workflows?
I know that there are other tools that are available. This one works really well for us. We have a lot of experience using it, which is probably the standard answer you've heard for several tools like this across this particular workshop. But it integrates well with our workflows, and we have a number of folks. We actually have a users group on campus for administering SwRI, and we pay for support through SchedMD, so it's really the right tool for how we do what we do. But it's the concept in general of using this type of scheduler is a modern workflow, and it is the right thing to be doing if you need to schedule hardware specifically. You don't have to use this tool to do it.
You may allude to the next question, but I'm going to ask again. How do you also manage manual users trying to connect to hardware through SLUM?
So the SLRM backend handles all this for me. I basically just say I want to be able to configure Open On Demand in order to have Jupyter Notebooks jump into stuff automatically, and that works. The SLRM scheduler service, the SLRM controller, basically deconflicts that. So automatic, as long as there's multiple enough resources for both things to happen at the same time, they just happen at the same time. If they don't, there's two things that can happen. It's generally, if your priorities are the same, it's going to be first come, first serve. And so you'll have to wait, and there's all sorts of instrumentation to let you know where you are in the queue and what's ahead of you and how long it's going to be. And if things end early, if you've moved up, the other piece of that is that it supports preemption. And so if you have higher priority jobs that need to run for whatever reason, you have a higher priority, then it can kick a job and automatically restart that job later after the preempted job the preempting job completes.
Any questions from the audience?
We have one more online. Do you allow commercial users to test proprietary software?
Yes, we should talk though. We have an Office of Sponsored Programs, and we have a mechanism for that, and we would develop a technology control plan to make sure that your proprietary software or proprietary tooling is not leaking into other parts of academia.
For your actual code base, do you run the SLRM job as a gating thing for merge? And how long are your SLRM jobs? Like, what sort of regression are you running?
So yes, I'm actually using this mechanism for, supporting a paper or a, presentation I'm doing for SmallSat that is comparing F prime and CFS. It takes as long as the jobs normally take. I mean, it depends on the project. For the demo here, this one on RISC-V happened to be about 15 minutes because that RISC-V platform is not particularly fast and it is not a parallelized job. But, you know, all of the standard types of things in that realm apply. Yeah.
I think that's it for questions. Thank you, Sterling.
All right.